The volume of juice in large bottles follows a normal distribution with a mean of 5.10 liters and a variance of 0.0102. Let's say L here follows the normal distribution. And the volume of small bottles of juice, let's say small bottles is denoted by S, follows a normal distribution with a mean of 2.51 and a variance of 0.0036. Part A, find the probability that the total volume of juice in 3 randomly chosen large bottles and 4 randomly chosen small bottles is less than 25.5 liters. Let's say T denotes the total volume of juice. So T here is given by the sum of 3 large bottles. So we have L1, L2, and L3. And also 4 small bottles. We have S1, S2, S3, and S4. Since L and S follows a normal distribution, the sum of normal distributions is still normal. We know that T follows a normal distribution. What we want to find is the mean and the variance of T. To find the mean of T, we find the expected value of T. That will give you the expected value of all that. We have L1 plus L2 plus L3, and we sum all the S also. The expected value of sum is the sum of the expected values. We have expected value of L1, expected value of L2, expected value of L3, plus the expected value of S1 through S4. Expected value of L is 5.10. Each of them has an expected value of 5.10. There are 3 of these. So we have 3 times 5.10. And we have 4 S's here. So we have 4 times the expected value of S, which is 2.51. And this has a value of 25.34. So we know that T here has a mean of 25.34. Now we need to find the variance as well. So the variance of T is the sum. Then we have the variance of all that. So we have the variance of L1, L2, L3, and then S1 through S4. Now the variance of a sum of random variables is just the sum of the variance. So we have variance of L1, L2, L3, and variance of S1 through S4. And this will give you 3 times the variance of L, which is 0.0102. And we have 4 of all that. So we have 0.0036. And we have a value of 0.045. That gives us the variance of T. We want to find the probability that T is less than 25.5. This is what we need to find. T is a normal distribution. We need to standardize, use the Z-score formula. This will be less than 25.5 minus the means, which is 25.34, divided by the standard deviation. We take the square root of the variance, which is 0.045. And that will give us the probability that Z is less than 0.754. We can find this probability directly from the standard normal table. So that will give us 0.7734 plus 0.0012. Because of the 4 here, we need to add the 0.0012. And that will give us 0.7746. To three significant figures, that is 0.775. Part B, find the probability that the volume of juice in a randomly chosen large bottles is at least twice the volume of a juice in a randomly chosen small bottles. So we need to find the probability that L is greater than or equals to twice means 2 times S. To find this, we need to just rewrite the inequality L minus 2S greater than or equals to 0. That is the probability that we need to find. We need to find the distribution of L minus 2S. L minus 2S still follows a normal distribution because it's just a linear combination of a normal distribution. To find the mean, we find the expected value of L minus 2S. This is the expected value of L minus 2 times the expected value of S. And that is 5.10 minus 2 times 2.51. That gives us a value of 0.08. We have 0.08 here. And then the variance of L minus 2S. That will give us the variance of L minus the square of 2. So when you multiply by 2, that is squared. So we add here 4 variance of S. Whatever that is a subtraction, we change it to an addition. Variance can only increase, not decrease. The variance of L is 0.0102 plus 4. Variance of S is 0.0036. That should give us a value of 0.0246. So we are 0.0246 here. The probability that we need to find is actually this probability. And we know the distribution of L minus 2S. So we standardize, and then we have Z greater than or equals to 0 minus 0.08 over the standard deviation. So the standard deviation is the square root of variance. We have 0.0246 here. And this will give us the probability that Z is greater than or equals to negative 0.510. This is the probability that we want. Probability Z greater than or equals to negative 0.510. This is a right tail probability. And from the symmetry, let's say this is 0.510. These two areas are the same. So instead of finding the probability that Z is greater than or equals to negative 0.510, we find the probability Z less than 0.510. And we can obtain this value directly from the standard normal table, which is 0.695.